The ocean is vast and mysterious. Its depths hold countless wonders. But one thing we know for sure, the ocean is salty. This saltiness, known as salinity, is a defining characteristic of seawater. What makes seawater salty? The answer lies in the dissolved salts within it. These salts come from various sources. They are carried into the ocean through natural processes. Understanding these processes is key to comprehending the ocean's chemistry. The ocean's salinity is not uniform throughout. It varies depending on factors like rainfall, evaporation, and freshwater inflow from rivers. However, the average salinity of seawater is about 35 parts per thousand. This means that in every 1,000 grams of seawater, there are approximately 35 grams of dissolved salts. Rain plays a crucial role in delivering salts to the ocean. As rainwater falls from the sky, it absorbs carbon dioxide from the atmosphere. This makes rainwater slightly acidic. When this slightly acidic rainwater falls on land, it erodes rocks. Rocks are made up of different minerals. Some of these minerals contain salts. As rainwater erodes rocks, it dissolves these salts, carrying them along in a dissolved state. Rivers act as conveyor belts, transporting the dissolved salts from the land to the ocean. Over millions of years, this continuous process has resulted in a significant accumulation of salts in the ocean. The constant influx of salts from rivers is a major contributor to the ocean's salinity. While rivers constantly deliver salts to the ocean's salinity remains relatively stable. This is because of another crucial process, evaporation. As the sun heats the surface of the ocean, water evaporates into the atmosphere. Importantly, when water evaporates, it leaves behind the dissolved salts. This process of evaporation acts to concentrate the salts in the remaining seawater. Imagine a pot of salt water on a stove. As the water boils and evaporates, the remaining water becomes saltier. Other factors also contribute to salinity variations in different parts of the ocean. For example, regions with high rainfall tend to have lower salinity due to the influx of fresh water. Conversely, areas with high evaporation rates, such as enclosed seas, often have higher salinity levels. Besides rain erosion and evaporation, there are other contributors to the ocean's salt content. Underwater volcanic activity plays a role in adding salts to the ocean. When volcanoes erupt underwater, they release dissolved minerals, including salts, into the surrounding water. Furthermore, hydrothermal vents, which are openings in the ocean floor where hot, mineral-rich water flows out, also contribute to the ocean's salinity. These vents release dissolved minerals, including salts, into the deep ocean. While these processes may seem small compared to the vastness of the ocean, their cumulative effect over millions of years has contributed to the ocean's saltiness. The balance between salt input from sources like rivers, volcanoes, and hydrothermal vents, and salt removal through processes like evaporation, maintains the ocean's overall salinity. Understanding the processes that govern ocean salinity is crucial for comprehending the ocean's overall health. Salinity plays a vital role in many aspects of the marine environment. It influences the distribution of marine life. It affects ocean currents and circulation patterns. Changes in salinity can have significant impacts on marine ecosystems. For example, excessive freshwater input from melting glaciers due to climate change can disrupt salinity balances, affecting marine organisms adapted to specific salinity ranges. By studying and monitoring ocean salinity, scientists can gain insights into the complex interactions between the ocean, atmosphere, and land. This knowledge is essential for predicting and mitigating the impacts of climate change on the ocean. It also helps us make informed decisions about managing and conserving our marine resources.